At 10:47 on the morning of September 22nd, 1967, Chief Engineer Hugh Keenlyside stood on the crest of the W.A.C. Bennett Dam, watching the first concrete being poured into forms that would eventually rise 183 meters above the Peace River Valley floor. 68 years old, 41 years in public service. He was supervising the construction of what would become the largest earth-filled dam in North America. A project that would either prove British Columbia could harness one of Canada's most powerful rivers to fuel industrial development, or become the most expensive hydroelectric failure ever attempted. The numbers made conventional dam engineers nervous. A barrier 2 kilometers wide across the Peace River. A reservoir that would flood 1,773 square kilometers of boreal forest and river valley, an area larger than the city of London, with 10 turbines generating 2,730 megawatts, enough to power every home in British Columbia with surplus for export. Construction costs estimated at $700 million in an era when BC's entire provincial budget was $400 million. Premier W.A.C. Bennett, for whom the dam would be named, had championed the project since 1957, convinced that cheap hydroelectric power would transform BC from a resource extraction economy into an industrial powerhouse. The Peace River dropped 760 meters from the Rocky Mountains to its confluence with the Slave River, wasting enormous hydroelectric potential by simply flowing through wilderness. But the Peace River Valley was 1,200 kilometers from Vancouver. The nearest transmission line was 400 kilometers away. Building a dam in that isolation, through northern winters where temperatures dropped to -45, it seemed impossible. Keenlyside had designed dams across Canada and understood that earth-filled construction could work where concrete dams would fail. The Peace River site sat on glacial till and bedrock, materials that could be excavated on site and compacted into a stable dam structure without importing millions of tons of concrete. The first concrete settled into the forms. Workers began the process that would continue for 6 years, eventually placing 43 million cubic meters of earth and rock into the largest earth-filled structure Canada had ever built. The Bennett Dam was rising. The problem began in the 1950s, when British Columbia's electricity demand was doubling every 7 years. The province depended on small hydroelectric plants on coastal rivers, systems that were fully developed with no expansion capacity. So, Vancouver's industries needed more power. The province's aluminum smelters, pulp mills, and mining operations consumed electricity faster than new capacity could be built. The Peace River represented untapped potential. The river drained 103,000 square kilometers of watershed, carrying an average flow of 1,900 cubic meters per second. Damming the Peace near Hudson's Hope would create a reservoir with enough storage to generate power year-round, regardless of seasonal flow variations. Premier Bennett created BC Hydro in 1961 by merging BC Electric Company and the BC Power Commission, giving the new Crown Corporation a mandate to develop the Peace River. The company hired Keenlyside as chairman and chief engineer, with instructions to build the largest hydroelectric project in Canadian history. The chief dam engineer, Dal Grauer, 52 years old in 1963, veteran of multiple hydroelectric projects, designed the earth-filled structure. The dam would be built by excavating glacial till from borrow pits adjacent to the site, compacting the material in layers, and creating a barrier wide enough at the base, 760 meters, to support the 183-meter height. Construction began in 1961. The first challenge was diverting the Peace River while building the dam. Engineers excavated 2 diversion tunnels, each 15 meters in diameter and 1,800 meters long, through bedrock on the river's north bank. The river was diverted through the tunnels in November 1965, allowing construction in the dry riverbed. Workers excavated the dam foundation to bedrock, removing unstable material that could allow seepage. The foundation reached depths of 60 meters in some sections, deeper than a 20-story building. Only bedrock or compacted glacial till remained. Then the fill began. Massive dump trucks, each carrying 85 tons of earth, ran continuously from borrow pits to the dam site. Compactors, weighing 50 tons, compressed each layer before the next was placed. The work continued through winters when temperatures made metal brittle and diesel engines difficult to start. 3 workers died during construction. 1 was crushed by a rockfall during tunnel excavation. 2 died when construction equipment overturned on access roads. The names: Thomas Mackenzie, 41, David Chen, 38, Robert Walsh, 34. If you want to see how Hugh Keenlyside engineered the largest earth-filled dam in North America under conditions that made failure seem inevitable, please hit that like button. It helps us share more forgotten stories like this. And please subscribe if you haven't already. Back to BC Hydro. The dam was completed in 1968. The diversion tunnels were sealed. Water began rising behind the barrier, gradually flooding the Peace River Valley and creating Williston Lake, named for BC Lands Minister Ray Williston, who had negotiated land acquisitions. The flooding was systematic and irreversible. Water rose at approximately 30 centimeters per day, submerging forests, drowning wildlife habitat, and covering indigenous ancestral lands. The reservoir took 3 years to fill completely, eventually covering 1,773 square kilometers, the largest reservoir in British Columbia. Indigenous communities lost traditional territories when the Sai-Kadeen and other First Nations watched ancestral lands disappear beneath water that would never recede. Grave sites were flooded. Hunting grounds were drowned. The government offered compensation, but no meaningful consultation. The powerhouse was constructed adjacent to the dam, a facility containing 10 turbines, each capable of generating 273 megawatts. Water from the reservoir dropped 183 meters through penstocks, struck turbine blades, and spun generators that produced electricity at 13,800 volts. The first unit came online in 1968. Power flowed south through transmission lines built across 1,200 kilometers of wilderness to Vancouver and the Lower Mainland. But BC Hydro wasn't finished. The Columbia River system offered similar potential. The Columbia River Treaty, signed with the United States in 1964, required BC to build 3 storage dams on the Columbia to regulate flow for downstream American hydroelectric plants. In exchange, the U.S. would pay Canada for the downstream power benefits. Meeka Dam, completed in 1973, was the centerpiece. Located 135 kilometers north of Revelstoke, the dam stands 244 meters high, one of the tallest dams in North America. The reservoir created Kinbasket Lake, flooding 430 square kilometers of valley. Chief Project Engineer William Plews, 56 years old in 1968, specialist in large dam construction, supervised excavation of over 22 million cubic meters of rock and placement of 8 million cubic meters of concrete. The dam's spillway could discharge 7,850 cubic meters per second, enough to fill an Olympic swimming pool in less than 1 second. Revelstoke Dam, completed in 1984. We added 2,480 megawatts to the Columbia system. The dam sits just upstream of the city of Revelstoke, creating a reservoir that extends 130 kilometers north. 4 turbines generate power that feeds directly into BC's grid. Combined with the Peace River system, BC Hydro's integrated network exceeded 12,000 megawatts of installed capacity by 1985. Today, BC Hydro operates 32 hydroelectric facilities, generating over 95% of British Columbia's electricity. The system serves 4.3 million customers through 80,000 kilometers of transmission and distribution lines. The Bennett Dam alone produces approximately 13,800 gigawatt-hours annually, enough to power 1.3 million homes. The Peace River system enables BC's resource industries. Our aluminum smelters at Kitimat consume massive amounts of electricity. Producing aluminum requires 15,000 kilowatt-hours per ton. Without cheap hydropower, the smelters couldn't operate economically. Mining operations across BC depend on reliable power for crushing, grinding, and smelting. Pulp mills require continuous electricity for mechanical pulping and chemical processing. The province's export economy depends on industrial facilities that consume electricity at rates that would be uneconomical without hydroelectric generation. And the entire provincial economy depends on the system functioning normally. A catastrophic failure of the Bennett Dam, whether from earthquake rupturing the structure, dam breach caused by overtopping during extreme flooding, or deliberate sabotage, would create immediate consequences across British Columbia and downstream territories. The reservoir contains 74 cubic kilometers of water. Sudden release would send a flood wave down the Peace River Valley, inundating communities including Fort St. John and reaching as far as the Northwest Territories. The town of Peace River, Alberta, 250 kilometers downstream, would be flooded within hours. Loss of 2,730 megawatts from the Bennett Dam would create immediate power deficits across BC. Industrial facilities would shut down. Residential areas would experience rolling blackouts. BC Hydro maintains interconnections with Alberta and the Pacific Northwest, but import capacity is limited to approximately 3,000 megawatts, insufficient to replace Bennett's output. When the economic impact would exceed $400 million per day as industrial production halted, aluminum smelters shut down, and commercial activity across the province ceased. Dams don't fail often, but doesn't fail often isn't can't fail. Hugh Keenlyside retired from BC Hydro in 1969 after overseeing completion of the Bennett Dam. He died in 1992 at age 93. The dam he engineered has operated for 56 years without structural failure, a testament to earth-filled construction that accounted for every variable except Indigenous land rights. Dal Grauer died in 1964 at age 53, before the Bennett Dam was completed. He never saw the reservoir fill or the turbines begin generating power. His engineering principles became the foundation for subsequent BC Hydro Dam projects. William Pleurs continued working on hydroelectric projects until his retirement in 1985. He died in 2003, age 91. Mica Dam remains one of the tallest dams in North America and a critical component of the Columbia River Treaty obligations. Premier W.A.C. Bennett lost power in 1972, but lived to see the dam system transform British Columbia's economy. He died in 1979 at age 78. The dam bearing his name generates enough electricity annually to power the entire province with surplus for export. BC Hydro operates 24 hours per day, 365 days per year. Control centers in Burnaby and Revelstoke monitor reservoir levels, turbine output, and transmission system stability. Water from Williston Lake flows through penstocks, strikes turbine blades, spins generators, and sends 2,730 megawatts south to Vancouver, 183 meters above the Peace River Valley floor. The Bennett Dam holds back 74 cubic kilometers of water. enough volume to flood the entire lower mainland of British Columbia if the structure failed. The system continues. British Columbia depends on it continuing. If this story moved you the way it moved us, do me a favor. Hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about infrastructure that powers provinces, real people, real engineering, real consequences. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. Now, you're not just a viewer. You're part of keeping these memories alive. Tell us your location. Tell us if you've worked in hydroelectric power or visited these dams. Just let us know you're here. Thank you for watching, and thank you for making sure Hugh Keenlyside, Dal Grauer, and the 3 workers who died building this system don't disappear into silence.